this final video we're going to talk a little bit about algorithm design and validation, two extremely important concepts. Now, in the real world, when you're actually given a problem, or certainly for a controlled assessment or a project, you will be asked to think. You're not going to be given the pseudocode. You might be, for the highest levels, for the genius levels, for the highest marks, you'll be asked to actually think for yourself. Now, for the matchmake feature, the idea is that, now, as you'll see that this doesn't actually work, but is it possible to make possible matches based on some sort of algorithm? Now, at Teach Yourself Python, we came up with this novel idea that it's possible that people who have different strengths would make good matches. Now, that could be true, that could be untrue, but this is just an idea, and this could be an algorithm that this dating site is going to use, and it's going to make millions. So, for instance, Ruth, very good at timekeeping. She's very, those sort of people are very sort of on the ball, efficient. But if two people who are very good at that sort of thing, efficiency, came together, they might clash. Whereas if she got together with someone who was very laid back and patient and lovely and gentle, that might be a better match. Now, how would you come up with an algorithm that would list, possibly in pairs, or in any way you can think of, all the people who are potential matches based on their keywords? Now, you might come up with an altogether completely different algorithm, but this is the one that we've set for now. For this particular one, we're not going to give you a solution, just want you to be able to think about it yourself. But remember, each user was given a strengths list, and each of these are actually a matching pair. So patience versus efficiency, sensitivity versus frankness. These are the opposing characteristics, so to speak. So timekeeping, laid back, submissiveness, leadership. One possible little pseudocode would be: open the file, you search and store the return results for any individuals that have strengths in the first pair, and then any individuals that have strengths in the second pair. So for instance, Ruth and Pikachu would be matched with Jonathan. They have complementary strengths. Think about how you might do that, how you might improve the algorithm, how you might go about even thinking of your own algorithm. Final consideration is one of the most important things, which is validation. You must validate a program. And validation just means that you allow for the user not to make too many mistakes, that the input they put in is valid. For instance, if I put in a K, that is invalid. Now, it's crashed the program, but it would have been good if it didn't crash the program and instead gave them some sort of validation text which said, no, that is not valid input, try 1 to 5. So validation is something that would be applied almost anywhere. So for instance, if I go into the registration menu, maybe I don't want a username which is only numbers. I would like a username to have at least a number, some text, maybe a capital letter. That's quite complex validation. As you go down, maybe you'd want the password to be at least 6 letters. That's a type of check validation where you're limiting or you're ensuring that the input is a certain length. The gender, you could make sure they don't spell it wrong. What if they couldn't spell and they spelt it like that instead of like that? You could give them options. Often if you had a GUI, you'd have a drop-down menu. Obviously with email, you could make sure it's a valid email in that it has an @ or it follows a particular format. So think about the validation. You can go back to the Solve and Learn series and look at the different ways in which validation has been approached. You can use regex, you can use it in a more specific or customized manner, but validation, as you've come to the end of your program, must be considered, written about, and implemented where possible.